Hello and welcome to this session. In the next two sessions, we will study about the behavioral elements that are present in the UML. In the previous sessions, we had studied so far the model of groups, group of diagrams like the classes diagrams, object diagrams, use case diagrams, etc. So whenever we are categorizing the system into static view and the dynamic view, the class diagrams, object diagrams comes under the static view. These are the diagrams wherein which the analyst tries to draw from the requirements that are being given by the client. So this becomes the communication between the analyst and the client. So these are basically the static diagrams wherein which they are easily represented by the analyst and shows to the clients, and then they will be able to understand the diagrams properly, and then if at all there are additional requirements, or else if at all there are some more modifications to be done or some more enhancements to be done, they will do accordingly. And once again he redraws the picture of the class diagrams, and once again he explains them to the clients in order to derive additional more requirements. Coming to the dynamic view, so these particular dynamic view diagrams helps the analyst to communicate with the team of the developers. So whenever the team of developers are developing some kind of programs, so the analyst will make sure that whatever the requirements that are given by the user are properly being converted into the kind of software. So the communication channel between the analyst and the team of developers are the dynamic view. In the dynamic views, we had seen earlier the use case diagrams. So these use case diagrams, what we had done is, we are taking the requirements not only from the clients, we are trying to take the requirements from the users also, who will be the end users for the system that is going to be developed. So those particular users also will give some sort of inputs, like the way the interface should look like, or the way the actual screen should look like, the way they want the items to be put on the menus and etc. So these are the things that will be provided by the users. So those particular requirements are also very much necessary. In that context, we had already seen some examples like the soda vending machine, etc. So in this particular session, let us talk about the behavior element that can be inputted in the UML diagrams. Behavior element is nothing but, whenever we are talking about the object, then that particular object during some course of time, like after the lapse of some time expiry, or else after the lapse of after an event occurs, that particular object tries to change. Suppose if that particular change is occurring for that object during the course of time, those particular changes also we have to incorporate in the UML diagrams. Those particular changes are nothing but state transitions. Those can be called as state transitions. So in this particular session, we will talk about how these particular state transitions can be incorporated in the UML diagrams using the state diagrams. So this particular new category called as the behavioral element category shows how parts of an UML diagram change over that time. So if at all you are taking some objects, if the behavior of that particular objects are trying to change during the course of time or during the system lapse of some sort of time, then those particular things we are trying to take care using this behavior element. So as time passes and events occur, changes takes place in the objects around us. This holds good not only for the objects around us, that is in the environment, this also holds good for the systems that we develop. So as the system interacts with the users and with the other systems, the objects that make up the system goes through some sort of changes which needs to be accommodated in the UML diagramming. So those particular things we can take care using the state diagrams. So one way to characterize the change in the system is to say that its objects change their state in response to events and to time. Suppose if the particular event is triggered, suppose if some event has happened, so with that particular action there is a kind of activity that needs to be initiated. So that particular thing we have to take care. What is the event that is occurred and what is the simultaneous action that is being done. So those two particular things we have to take care with respect to the time. So this particular UML state diagram captures these kinds of state changes. Like suppose if you take the example of when I switch on the light glows. So when I switches off, so the lights offs. So there are two states I can mention over here. By pressing on, the light is glowing. By pressing off, the light is putting off. So these particular two changes, suppose if I want to convert them into the UML, there are two states I have to represent. One is on and the other is the off. Likewise, you can give as many examples as you can. A state diagram shows the states of a single object. This particular thing you have to remember. So for each and every object, you have to define various states. What are the possible events that can be occurred, and what are the different states whenever those occur, those particular respective events occurring. So what are the actions that needs to be taken care? Those particular aspects you have to take care for each and every object. It presents the states of an object and respective transitions, showing their starting points and end points of a sequence of state changes. Suppose if an object is in its initial state, if some event occurs, then there will be some sort of action. So after that particular action is there, suppose if another event occurs, then it may be shifting to another transition, like it may be shifting to another state. So all those states, right from the starting point, like the initial point, till the end point it reaches, we have to draw these particular all transitions in the state diagrams. So let us see the conventions that we have to take care whenever we are drawing the state diagrams using UML 2.0. So the state I can represent using a rounded rectangle. So here, whenever we are trying to put it in the form of a state diagram, I should not take directly the rectangle. So rectangle is nothing but whenever we represent a class, we take it as a rectangle. But whenever we are trying to represent it as a state of an object, we have to take the corners as some sort of rounded corners, and is called as rounded rectangle. So that represents a state along with a solid line and a arrowhead. This is meant for taking care of the transition part. So there is a state, and after some event is occurred, I have to shift to another state. So that particular state transition from the initial state to the next state, I have to represent using an arrow with a arrowhead, solid line with a arrowhead. The arrowhead points to the state being transitioned into. So from this particular state to another state. So that particular arrowhead should be pointed to the next state. So there, the head position should be towards the next state. The solid circle that symbolizes a starting point, and the bull's eye that symbolizes an end point. For each and every state, we have to take care of the start point. What is the initial point? What is the initial state? So that particular state we have to represent using a start point, like a round circle. And then the end point, we can give it as a bull's eye. So these particular two things you have to remember. It is customary to capitalize the initial letter of a state's name. So whenever we are trying to put this rounded rectangle in order to represent a state, we have to put some sort of heading also, like we have to give the name of that particular state, in which state it is right now. So that particular state's name you have to represent using a capital letter, and later on you can put it as a lowercase letters. So for each and every state, the name should be ending with ing. Suppose if I am representing some sort of model for fax, so I have to take the name as faxing. So that particular continuous tense we have to use in order to state a name for a state. Then let us see one example here. So this is a kind of typical representation of a state diagram using the conventions. Here I am taking the rounded rectangle as a state. So this particular rounded rectangle represents a state, and this particular circle represents the starting point of the state, and this particular solid line with the arrowhead is that transition. Look here, the bull's eye represents the ending point of the state diagram. So suppose if I go into the details of the state diagram, I have to put one name for the state which will be ending with ing. This is the common convention I have to follow whenever there is a whenever I have to represent the state diagram. Suppose if there is some sort of restriction to put ing, you can go for an idealistic situation by keeping a relevant name to that particular state. And then I have to mention the activities. In the class diagrams, we mention the class name, and then we'll be mentioning the operations associated with that particular class. But whenever I am trying to represent the state diagram, I have to take care two aspects. I have to represent one, the state's name, and the other, the activities that I can perform with the state. So these two components I have to place in the state diagram. So in order to categorize the activities, one thing is there will be two components that will be existing in a state diagram. One is the name of the state and the other is the activities. So how to categorize these activities? There are three categories associated with the state diagram. One is the entry activity. So in this particular entry activity, we will be looking into what happens when the system enters that particular state. So whenever the state is entered, what happens? That particular thing should be entered as the entry level. And then there is the next category called as the exit. What happens when the system leaves the state? So what is the thing that will be? That is the outcome. So one is the input kind of thing and the exit is nothing but the output kind of thing. So between these particular entry and exit, I have to mention so many do performances like do activities. So what are those? What happens while the system is in that particular state? So that particular thing I have to represent. Suppose whenever I am performing some sort of activity, what happens? So that particular thing I have to write by putting a slash, by dividing that particular do with a kind of slash. Let us see one example so that you can understand the concept very clearly. So this is the kind of case study. In a fax machine, there are altogether one state I am trying to take, that is the faxing state. So whenever the machine is in the faxing state, like in the transmission state, the machine engages in the activities of adding a date stamp. So whenever I am trying to send a fax to other person, it automatically includes the time, it automatically includes the date, it automatically includes the fax number that is being transmitted from, and then it may be including the owner's name also. So these particular four things will be happening in this particular faxing state. So other activities may be it pulls the pages through the fax machine and then it paginates the fax and completes the transmission. These are the other activities that are included. While the machine is in idle, it presents the date and time on a display. So the first case I am observing here is the faxing state. So here this is a kind of state wherein which some sort of activity is going on. And the next state I am considering over here is the idle state. So whenever the fax machine is idle, it just displays the date and time on its display, LCD. So these are the two states I am trying to model. So look here. So one state I had represent as faxing state and the other state I am putting it as an idle state. So in the faxing state, I am writing the three categories what we had talked earlier. One is the entry category, second is the exit category, and third are the do categories. So in the entry category, I have to mention key in remote fax number. So the other end fax number I have to quote here, key in the remote fax number. In the exit condition, it is nothing but it completes the transmission. So in the exit condition, after the faxing is over, it completes the complete transmission. And then during this particular thing, so I have to mention the do categories also. One thing is it adds the date, it adds time, and then it adds the telephone number, and then it adds the owner's name, it pull pages through the fax machine, and then it paginates. These are some of the do activities that we can consider with the faxing state. So let us see the second state. Second state is the idle state. Here also I have to enter the entry category, I have to enter the exit category, and I have to enter the do categories as well. So in the do category, it will do only two things, that is it will displace the time, it will displace the date, and then it will end the transmission. And next, after exit is over, it is looking for next transmission to put on. So these particular two states I had put it over here. So first state is faxing, and after that particular faxing is over, then it will be reaching to the idle state. Whenever there is another transmission document that needs to be sent through fax, then it once again shifts to the faxing state. Likewise, we can model this particular faxing model. So adding details to the transitions, events and actions. So whenever we are talking about the solid line with the arrowhead, so that is nothing but a transition is taking place from one state to the other state. In that particular transition also we can give some sort of comments, we can provide some sort of details. So you can also add some details to the transition lines. Upon the solid lines with the arrowheads, I can put some sort of message. So that particular message indicates an event that causes a transition to occur. That is called as a trigger event. Suppose when a particular event is triggered, like suppose if I am putting on the switch in on position, so I am triggering the event. Suppose if I am taking off, like putting off, I am once again triggering the event to happen. When that particular event, whenever I am switching on, that particular light is glowing. So that is the thing simultaneously going on whenever I am whenever I am doing some sort of action. So that particular event that causes a transition to occur is called as a trigger event, and the computation that executes and makes that state change happen, that is called as the action part. One thing is event happening and the other thing is simultaneously the action upon the event. So both the things I can represent on the state diagrams. A transition can also occur because of an activity in a state is called as triggerless action or less triggerless transition. Some of the events I can quote, like after a delay of certain time interval, automatically the present state may be changing it to a next state. So here I am not at all triggering any event. So this particular event after a delay of some sort of time and other things, so this particular thing I can categorize as a triggerless event. I am not triggering anything, but it happens automatically. So this particular state this particular transition, I can call it as a triggerless transition or as a triggerless event. So let us see one simple example. We are all aware of this Windows operating system. It comes under graphical user interface. Let us take only 3 states. One is the initializing state, working state and shutting down state. So this particular graphical user interface, that is the operating system, may be in any of the 3 states. Either it may be in a initializing state, and then it shifts to the working state, and after some sort of trigger event is happened, like suppose if I am putting some sort of command button called shutdown button, if I press, then it is moving to the shutdown phase. So all the 3 events here are being depicted. One is here I am showing the start symbol, and this particular initializing is taking place. For this particular initializing to be happened, I am pressing the button, like the power on button. After that particular action is triggered, what it is doing? It is initializing. Initializing is nothing but that is the state wherein which the boot up is performed in the system. Like the program that is there in the ROM lifts the operating system and then put it in the RAM and initializes the operating system so that it can control the overall machine. So that particular boot up procedure is started. That is the activity that is started in the while it is in the initializing state. So once that particular state is done, initialization process is over, it is shifting to the working state. In this working state, I can activate any kind of program, I can activate any kind of software, I can activate any kind of tool so that I can work with the machine using the graphical user interface. And then suppose if I trigger the event called as the shutdown event, then automatically the system is shutting down. So here I am putting some sort of trigger event called as the shutdown event to fire. So shutdown event, once it is fired, automatically the system is shutting down. And this particular bullseye is nothing but this is the endpoint for the state transitions. So these are the 3 things you can identify in this particular figure. So this particular figure not only ends here. So the state diagram of GUI with the screen saving state. Suppose let us take the state of the working state here in the GUI. After the initialization is over, and after that GUI appears on the desktop. So it is ready to, it is giving a provision to work with the programs and the tools that are available on the system. So in that particular working state, suppose if you are not working and if you are sitting just idle before the system for some sort of time, and that particular system is activated by a screensaver. So after a delay of time, once again the screensaver is appearing in order to protect the system, in order to save the content that are there in the system. So that particular screen saving facility, once the time is out, then that particular screensaver is coming into the coming and taking over the system's display. So if at all after a long while, suppose if I just move the mouse, or else if I press some sort of key on the keyboard, once again it allows me to work with the system. So here I am trying to depict these particular things once again, like I am putting once again there is a state called as the screen saving state, but this particular screen saving state is happening once the time is out. Suppose if I had given some 15 minutes of time delay, I had put the time as 15 minutes. So after the timeout of 15 minutes, it is going to display the screensaver. So that particular condition is called as the guard condition, G-U-A-R-D. That particular condition I am putting is the guard condition. After the guard condition is met, the working state is shifting to the screen saving state. And once I am pressing the mouse, or once I am pressing the key button, once again it is regaining the previous state, like from the screen saving state to the working state. And once the trigger event called as the shutdown event is fired, then shutting down is happening. So this particular guard condition also I can put with some of the states. So next let us look into the substates. So not only the guard condition doesn't completely fulfill the GUI, so working with the state behind the scenes. So suppose if you take the GUI is constantly waiting for you to do something. So once, suppose if take an example as the working state here. So whenever I am trying to work with the working state, it is allowing you to press the keyboard, or if it is allowing you to move the mouse in order to do some sort of actions, and that according as per the actions it is displaying some sort of figures or some sort of alphabets on the system. So whatever we are trying to do with the keyboard or whatever we are trying to do with the mouse, it is always giving a kind of response from the system side also. Suppose if I am pressing A, I am opening the MS Office Word, and then I am pressing some sort of A in the document. So it displays immediately the A on the document. Suppose if I am moving the mouse, it is obviously showing the movement of the mouse. So whenever I am trying to do something, whenever I am trying to interact the system with the keyboard or mouse, it is obviously visualizing those particular things on the desktop. So simultaneously these particular things are happening. So there are certain things wherein which within the states there are something called as substates happening. So sometimes a state consists of some sort of substates too. So some changes are changes of state because these states resides within the states. So they are called as the substates. One substates, there are two categories in these particular substates. One is the sequential substate and the second is the concurrent substate. Suppose within the working, let us take one example here. The first category is the sequential substate. So sequential substate is nothing but within the state there may be existing several substates, and those particular substates also will be happening one by one. So those particular sequence is called as the sequential substates. So sequential substates occur one after the other. Recapping the aforementioned substates within the GUI working state, you have this sequence. So first of all, it will be awaiting for the user's input. Then it will be registering user's input. Then it will be visualizing that particular user's input through the display. So these are the three substates in the working state. Let us visualize using a UML diagram. So in this diagram, let us see awaiting user input. This is the working state. Here I had shown the complete thing is the working state, and within the working state, there are three substates. One is awaiting user's input, second is registering user's input, and then third is visualizing user's input. So the system is waiting for the inputs in this particular state. So once the user gives the input, then that particular state is transitioned to registering input. So the system is trying to take the input from the user. It is registering the values, and depending upon the values or depending upon the action that is given by the user's inputs, it is visualizing the user's input on the desktop, or else some sort of peripheral is activated. So these three things, these three substates are called as the sequential substates. Why? Because first it is awaiting, then it is registering, and then it is visualizing. These three are three separate states, and from one state it is moving on to the other states, that too in a sequential manner. So these three substates comes as a kind of sequential substates for the working state. So once again the visualization part is over, then once again it is ready to take the inputs from the user. So this is a kind of cyclic expression or a cyclic equation, wherein which the three things are happening sequentially within the working state. So let us go to the next category in the substate called as the concurrent substate. So concurrent substate is nothing but within the working state, the GUI is not just waiting for you, but it is also watching the system clock and updating an application's display after a specific interval. So for example, an application might include an on-screen clock that the GUI has to update. So in the concurrent substates, what will be happening is, all this is going on at the same time as the sequence I just discussed. Although each sequence is of course a set of sequential substates, the two sequences are concurrent with one another. This represents the concurrency with a dotted line between the concurrent states. So in the concurrent substates, what happens is, suppose if there are several substates which are moving on or which are trying to take place concurrently. So at the same time, many substates are trying to be activated. So that particular thing is called as a concurrency with respect to the state. So there may be several things, several substates happening in the same state. Suppose if you take the case, a simple example as a system, suppose if there is a kind of display on the system itself, wherein which I have to update the system clock for each and every minute. So after a lapse of each and every minute, I have to update the system. But in order to expiry of that particular 1 minute, in the behind the screens, behind the system, it will be counting the seconds part also. So for each and every, suppose if I am working with the system, suppose if I am keying in, simultaneously behind the scene, the system is taking care to update the clock also on the display. So two parallel activities, two concurrent activities are happening here. One thing is, it is trying to take the input from the user, it is trying to register the values given by the user, it is trying to display or visualize those particular values given by the user on the display. Simultaneously, it is taking care of the system clock that needs to be updated for each and every minute. So those particular concurrent events takes, suppose if you want to represent those particular concurrent things that needs to be taken care using the UML, you will be using the concurrent substrates within the state. Let us see the figure. So here the working state is the main state, and within the working state, these three are the awaiting, registering and visualizing are the sequential substates, and then watching system clock, updating the display parallel to these particular three activities. Suppose if there are three substates parallel to those particular three sequential substates, the concurrent substates are also being taken care. So we have to differentiate the sequential substates with the concurrent substates by putting a dotted line between. So within the working states, there are two categories. One is the sequential states that I had represented over here, and then the concurrent substrates I had represented over here, and then these particular two things I had separated using a dotted line. So what will happen? What is happening here? Watching the system clock after a frequent interval, for every 1 minute, it is updating the display. Once again, it is moving on to the watching the system clock. Once again, it is displaying. But this particular activity is concurrently being done with the earlier 3 sequential substrates. So let us talk about a composite state. A state that consists of nothing but the sequential substrates is also called as a composite state. Composite state is nothing but if a state is consisting of several substrates, like we had seen in the earlier case. One is the awaiting case, second it is shifting to the registering value case, and then it is shifting to the visualization case. So these particular, suppose if there are several states, several sequential substrates in a state, that particular thing we can call it as a composite kind of state, wherein which it is having several states, several substates, several sequential states and other things. So we can call that particular state as a composite state. Here I can give you an example as the GUI working state. So let us see the history states. History state is nothing but, here we had seen 2 states. One is the working state and the other is the screen saving state. So after a delay or after a lapse of some 15 minutes, automatically that particular system is moving to the screen saving state. Suppose if the user is not disturbing the keyboard or the mouse. So once that particular state is reached, like the screen saving state is reached, then suppose if I press some sort of keystroke or the mouse button, suppose if I just press one key, then automatically it is moving on to the previous state. So that particular history can also be depicted on the UML diagram, that too on the state diagram. A history state indicates that a composite state remembers its substrate when the object transitions out of that particular composite state. Like suppose if in the history state is nothing but it is a kind of state wherein which it remembers what the previous thing has happened. That particular registry is being done in the history state. It indicates that a composite state remembers its substate when the object transitions out of that particular composite state happened. So that particular thing it remembers, and after the event happened, like suppose if I press the key, or if I just move the mouse, then automatically previous state is being regained. So that particular registry values are stored in the history states. A history state may be either shallow or deep. There are 2 categories once again in the history states. One is shallow and the other is deep. In the shallow, history remembers only the top level of the substrate. Suppose if whatever happened very recently, that particular substrates may be regained, and the action pertaining to that particular thing will be happening. Suppose if you take the case of the deep history is nothing but it remembers at all levels of the substrates. Suppose if something has happened just now, and then after the 10 minutes, suppose if I am just moving on to the previous state, it completely displays or completely take care whatever that I had ended previously 10 minutes before. So that particular thing is called as the deep history. So this particular history and the deep history I can preserve using a symbol called as H symbol. So in order to mention some sort of history state to be preserved on the state diagram, I have to put some circle and then I have to take capital letter H. So that particular H within a circle represents that there is a history state. Suppose if I mention H star, then that is nothing but it is representing a kind of deep history case. So let us see in the diagram. So here this is the working state for the GUI, and this particular working state I had represented the sequential substrates as well as the concurrent substrates. So once the timed out, so this particular substrate is moving to screen saving state, or else there is a state attached to this particular working state in such a way that once the time is out, then it will be moving to the screening state, or else once the keystroke or mouse movement is done, then it is regaining to the working state. So these particular 2 things I am taking care by putting, look here, by putting a solid arrow with a H inside the circle. So H inside the circle is nothing but that particular H inside the circle is once again connected to the awaiting user's input. So I am working with the system. I kept away for 10 minutes, 15 minutes, and then that particular system went on to the screen saving mode or screen saving state. And once I had pressed the key button, or else once I had moved the mouse, once again it is moving to the substate wherein which it is waiting for the user's input. So that's why I had connected this particular solid arrow with the H to the awaiting user input. So that is the position it should regain from the screen saving position. Then in UML 2.0 there is there is also a kind of indication called as the connection points, wherein which new state relevant symbols were introduced called as the connection points. They represent points of entry into a state or exits out of a state. So earlier we were taking care of these particular two states in earlier versions of 1.2 and all. We are putting some starting point with a kind of circle, and then we are like ending that particular state diagram by keeping the bull's eye. But in the UML 2.0 there is a new thing happened, or else new category introduced, that is called as the connection point. In this connection points, they represent the points of entry. Suppose if there are several entry points for that particular state, then I can mention the entry point, as well as suppose if there are one or many exit points out of that particular state, I can mention the exit points also. Let us see one simple example over here. So here entry points and exit point in a UML state diagram. So suppose if I take the case of a simple case of a library situation residing on a shelf. Suppose if I am reserving that particular book, then it is being, once I am being checked out, I am taking that particular book and I am checking out. So this particular entry point and the exit point. So this particular state being checked out with a book I can check out, or without any. Suppose if it is not found on the shelf, I can check without the book also. Suppose if that particular book exists but it is been reserved by somebody, and it is not being, it may not be in a, the librarian may not be in a position to issue that particular book, I can refer the book then and there itself, and I can quit from this particular state from here, from the quit, from the exit point. So there are several entries for this particular state. So there is not one particular entry, but there are several entries for this particular state, and there is one exit point. So these particular entry points and exit point I can mention on the UML diagram using the connection points. That too in the earlier versions I don't have, but in the latest version like UML 2.0 I have the connection point system. Then why are these state diagrams important? So till now we had studied about the state diagrams and various examples. So what actually it is trying to present to the user who is using this state diagram? That too for each and every state, for each and every object, I am trying to derive so many states, so many possible states. So what are the possible events that may be occurring, and what are the actions that needs to be taken whenever the event is happened. So both the things I have to take care. So it is nothing but it is giving you a clear picture. So like the if condition, and then it is meeting the else condition also. So there may be several possibilities and there may be several choices, so that for each and every state transition I can easily identify the action that is been taking place, and the starting point of that particular state and ending point of that particular state also I can depict. So these will be helping the analysts, designers and developers understand the behavior of the objects in a system. So the object is not remaining standstill. So this particular object during the course of time, it is changing from one state to the other state. So these particular things I am trying to track. So these particular things I am trying to model them in the system model. So these particular things are helping the analysts. These are helping the analysts to analyze various possible states and various events that may be occurring, and the respective actions that needs to be taken care. And it is also helping the designers at the design stage. So this may be the screen, and after that, after the happening of this particular event, the whole interface may be changing. So the designers also are trying to take the inputs from these state diagrams. And the last part is the developers part. Developers are easily made understandable by the analyst. So this is a possible situation happening over here, and then this particular thing needs to be taken care in the program part by taking some sort of if then else statements, etc. So there may be several conditions which may be satisfying, or there may be several choices which needs to be served. So those particular things the developer should take care by understanding the actual concept given by the analyst or given by the client. So class diagrams and corresponding object diagram shows the static aspects, whereas the state diagram shows the change in the states. Not only it is giving you the dynamic view, but it is completely giving you the state, the present state, and after the due course of time, in which particular state it is going to be. So those particular things it is trying to show. So like we had discussed some of the examples in our session, let us see some of the exercises that you can do at your home. Suppose if you are designing a toaster, create a state diagram that tracks the states of bread in the toaster, include necessary triggering events, actions, and guard conditions. So these particular thing you have to model. So here for each and every object, so suppose if you take the toaster itself as an object, then on position, then running position, or else toasting position you can take, and then the switched off position. Like the fax machine we had seen. So here you can put this particular state as toasting. So you can give the entry point, entry category, you can give the exit category, and you can use various do categories like do activities also. So what is the idle state? What is the toasting state? These particular things you have to give, and you have to mention the triggering events also, and you have to mention the corresponding actions, and you have to give the guard conditions also. Suppose if that particular toaster is timed for 5 minutes or else 2 minutes. So after that particular guard condition is met, what it is going to be, whether the sandwich is popped off. So those particular things you have to categorize, you have to model this particular thing using the state diagram. The next question is, draw a diagram of the screen saving state that includes concurrent substates. So within the screen saving state also, it includes some sort of concurrent substates. So those particular things you have to track, and you have to present them in the form of a state diagram, that you have to include the concurrent substates. So this is the clear big picture of the UML. We had discussed earlier the structural elements, like the class is a structural element, actor in the use case is a structural element, use case is a structural element, interface is a structural element. Like in the relationship, we have seen the association part, generalization, dependency, realization. In the grouping part, we had grouped some sort of things into a kind of package. Like extension also comes under the grouping category. Like in the behavior element, just now we had seen the state diagrams, and in the annotation part, a note is called as an annotation part. So hope I guess that you had understood today's concept. So with this kind of exercises I had given at the end, please try them and look this particular state diagram as a useful concept for your UML diagramming. I hope you had understood today's session. Thank you.